In this video, I want to have a look at geometric proofs using vectors. So our first step is always going to be to draw a diagram if one isn't already given to you. Then we're going to label all the points on that diagram, and we're going to introduce some vectors to be able to use in our proof. Then depending what our question is and what we're trying to prove, we might be using the sum or the scalar product of vectors or the dot product of vectors to complete that proof. There are a few things that come up quite often in our geometric proofs that it's good to remember. So the first thing is that parallel vectors are scalar multiples of each other. The second point is that dot products are going to be 0 if our two vectors are perpendicular, assuming they're both non-zero. The third point is if we take the dot product of a vector with itself, then we're going to get the length of that vector squared as our answer. And the fourth one is that the dot product is distributive. So if we have the dot product of P with the dot product of Q plus R, then that's the same thing as doing the dot product of P and Q plus the dot product of Q and R. So let's have a look at some examples. All right, so our first example says, consider a triangle ABC with PQR being the midpoints of our three sides. We want to show that the sum of the vectors from the midpoints of each side to the opposite vertex is 0. So let's translate that into a diagram. So we're going to draw a triangle, ABC. Best I can without a ruler. Okay, let's call that triangle A, B, C. Now we know that the midpoints are P, Q, and R. Okay, so that's what's given to us in that first sentence. Then it asks us to show that the sum of the vectors from the midpoint of each side to the opposite vertex is 0. So if we draw in those vectors, so let's draw them in black so we can see what we're doing. So from the midpoint of each side to the opposite vertex. So we're going to have this vector here from P to C. Then we're going to have Q to A. And we're going to have R to B. And we want to show that the sum of those three vectors is 0. So what we're trying to prove is that PC, vector PC, plus vector QA, plus vector RB, that all of those are equal to 0. Okay. So we've drawn our diagram, we've figured out what we need to prove. The next thing we're going to introduce is some vectors in there to be able to answer our question. So let's let vector A be. So if we go from A to B, let's just call that A. Just to make things a little bit simpler, we'll say the vector from B to C, we'll call that vector B. And the vector from C to A, we're going to call that vector C. Oop, put an equal sign in there instead, just to make the notation just a little bit easier. Okay, so what we're trying to prove is this. So let's start off with PC. That's going to equal. So we're trying to get from this point here over to this point here. So the way we could do that is we could go from P up to B and then down to C. So if we were to do that, we would end up with, well, this vector here is a half A, because it's only half the distance of the vector from A to B, so half A, and then we're going to go down along the side BC, so plus the vector B. If we do the same thing for the other two sides, vector QA, from Q, we're going to go down here to C, and then we're going to go all the way along here to A to get this vector here. So if we add those two together, we'll get the vector QA. So that's going to give us, well, that's a half of vector B going along this side, and then we're going to add the vector C in. And our last one, if we do RB, so if we go along this side here, and then we can add this whole vector on along there. So if we do that, we'll end up with a half C plus A. Okay, now if we add all of those together, that's going to give us, half A plus B plus a half B plus C plus a half C plus A. Now, if we simplify that, we can pull it out as a half outside of A plus B plus C. And then we've also got the ones that were whole already. So we've got plus A plus B plus C. But what's important about A, B, and C is that they took us from point A up to B, down to C, and back to A. So when we add A, B, and C together, we end up back at our original starting point. So these sums, A plus B plus C, is just equal to 0 because we end up exactly where we started. So what that means is that we have a half times 0 plus 0, and we just end up with 0 as our final answer. Our second example asks us to consider a triangle ABC where P is the midpoint of AB and we have a right angle at C. Then we're asked to prove that the circle with diameter AB passes through the point C. So let's draw ourselves a diagram. So we're trying to prove that a circle with diameter AB, so if we have a circle with this as our diameter, then it's also going to pass through this point C here. So what that means we're going to have to prove is that this distance here, PC, is the same length as these ones because it would have to be a radius of the circle for the circle to pass through it. So just to confirm that, and just to write that down, we're going to prove that PC, the length PC, is equal to the length PA. Or we could have done PB as well. Either way works. Okay, so that's what we're going to try and prove. Now let's introduce some vectors. Okay, so I'm going to let PA, the vector PA, I'm going to call that vector U. So from P to A going this way is going to be our vector U, which then means that this one going from P to B, well, that's going to be exactly the same length, but going in the opposite direction. So that means that PB would be minus U if it's going out here. I'm also going to call PC, so the vector PC, I'm going to call that vector V. Okay, the other piece of information that's given to us is this right angle here. So if we have a think about what we've done with vectors and right angles, that right angle means that if we take AC, the vector AC, and we take the dot product with the vector BC, because those two lines are perpendicular, we would end up with 0. Okay, so we can use that. Let's figure out what AC and BC are. So if we look at AC here, well, we've got these two vectors, U and V, which I didn't label. So AC would be equal to V minus U. And then BC, which is this one here, going from B to C, so again down to this corner, would be V minus this one here, which is minus U. And we know that that has to be equal to 0. So if we go through and fix up that double negative there to start with, we're going to have V minus U, dot product of V plus U. And we're going to go and expand that out. So we're going to have the dot product of V with itself, plus the dot product of V with U, minus the dot product of U with V, plus the dot product, minus the dot product of U with itself. And that's going to equal 0. Now, we know that the order doesn't matter, so VU and UV, those dot products are the same, so they're going to cancel each other out. And we know also that the dot product of something with itself is equivalent to the length of that vector squared. So we end up with the length of the vector V squared minus the length of the vector U squared equaling 0. If we rearrange that, we would end up with the length of the vector V squared equaling the length of the vector U squared. Sorry, that should be a U, not a V on that side there. Now, because we're talking lengths and things can't be negative, that means then that the length of the vector V has to be equal to the length of the vector U. Therefore, PC equals PA. And then you can write a conclusion about the fact that PC is a radius of the circle with diameter AB that passes through C.